that is x plus iy, if I am writing, is as r cos theta plus I sin theta, that is your r cos theta plus iota times r sin theta. And I have mentioned you that two complex numbers are equal if their corresponding real parts and imaginary parts are equal. So, you apply that property over here. So, this gives you x is equal to r cos theta, y is equal to r sin theta. Now, first of all, I write x square plus y square, that is your r square cos square theta plus sin square theta, that is nothing but r square. So, r I write it as square root x square plus y square. And if I divide these two relations, then theta is equal to, or rather tan theta is equal to y upon x. So, well, in short, what I have done, I started with this complex number x plus iota y, and I wish to write this number in this form, that is r cos theta plus iota sin theta. These are two complex numbers, so equating their real and imaginary parts, I get r is equal to square root of x square plus y square, and tan theta is equal to y upon x. Well, this r is known as usually the modulus of z, that is mod z is equal to x square plus y square. And this theta, this is known as the argument of z. And this representation of this complex number in this form, that is z is equal to r cos theta plus iota sin theta, is known as the polar representation of a complex number. And this z, rather mod z, this is known as the absolute value of z or the modulus of z, and theta, not tan theta, theta is known as the argument of z. And those who know a bit trigonometry, you can write theta is equal to tan inverse y upon x. But I do not assume that you have done this much of trigonometry. But here one thing is very important, that you have to find out, if you have to find out the argument of a complex number, then you have to find out that value of theta which is satisfying both these equations. For example, suppose this r cos theta is negative, r sin theta is also negative, and you find out tan theta, that will be positive. That does not mean your theta is lying in the first quadrant. You have to choose that theta for which cos theta and sin theta both are negative, but tan theta is positive. So, here you have to be careful while calculating the argument of this complex number z. Then one more thing, that is the properties. What are the properties of complex, let us say this modulus and argument? Well, I do not have all that enough time, but one important property I would like to define, that or state rather, mod of z1 plus z2. If you are given two complex numbers, namely z1 and z2, and if you find out mod of z1 plus z2, then this is less than or equal to mod z1 plus mod z2. This is a very important property. Well, geometrically, if you observe this property, its proof is trivial. Why it is trivial? Because all of you know, if you have a triangle, in a triangle sum of two sides is always greater than the third, and that is why it is referred as the triangle inequality. So, z1 plus z2 is less than this, and let us consider z1 is equal to r1 cos theta 1 plus, and take another number z2 is equal to r2 cos theta 2 plus I sin theta 2. I have the normal multiplication, that is z1 plus z2 is r1 r2 cos theta 1 cos theta 2 minus sin theta 1 sin theta 2 plus iota cos theta 1 sin theta 2 sin theta 1 cos theta 2. This is just trivial multiplication. I have not done any mathematics, I have not used any mathematics. You are given these two numbers z1 and z2. I can always write these two numbers in this form, as I have just mentioned, that is merely the polar representation of a complex number, and I have just taken the ordinary multiplication r1 multiplied by r2 cos theta 1 cos theta 2, and I have just used one property, that iota square is minus 1. I have taken real parts plus imaginary part, and this is the way how you represent a complex number. Now, I will use just a very trivial type of result. This is something, as you remember, cos A cos B minus sin A sin B, that is cos of A plus B. So, this is cos theta 1 plus theta 2 plus I theta 1 plus theta 2. So, without doing any serious calculation or any serious mathematics, I have merely written z1 z2 is equal to r1 r2 into cos of theta 1 plus theta 2 plus iota sin theta 1 plus theta 2, where z1 I choose r1 cos theta 1 plus iota sin theta 1, and similar expression for z2. Now you look, this R1, this is your mod of Z1. R1 and similarly R2 is mod of Z2. And this theta, that was your amplitude of or argument of Z1. Similarly, this is the argument of Z2. Now forget those expressions, you come to this expressions, that is your Z1, Z2. Now according to your polar representation, R1, R2, that is nothing but this quantity is mod of Z1 into Z2. And R1 is also, so this is R1, R2, and R1 was your mod of Z1, R2 was mod of Z2. So just with the help of polar representation of complex number, I have proved an important property, that is argument of Z1, Z2 will be and of course mod of Z1, Z2 is mod Z1, Z2. This is merely the consequence of the ordinary multiplication of two complex numbers, and this property, well, whose proof unfortunately I could not give. So these three basic properties which I have mentioned and two of them I have shown, they are important properties, and rest of the algebra of numbers will be taught you later. And thank you very much. I stop here, meeting you sometime again. Once again, thank you.